exciting class. So we are going to look at our third part on a topic, further logarithm, and we are going to be looking at now the logarithmic equations. So in this case, it's where you're going to be having an equal sign. That one, we're going to see how do we go about it. And in this case, the major part in this topic is those understanding the logarithms laws. And when you have the four rules that we did introduce in the first part, these are the ones that you're going to be able to use even when it comes to this part. And for us to be able to see different ways of how questions are asked, we're going to look at various examples so that you can be able to conclude this topic. And I'm going to start with example 1 there. We have been told to solve for x in those 5 different questions, and we are going to go through them and we see how we can go to do so. Let's start with the first one. We have been told to solve for x in the log of 81 base 3 is equals to x. So when you get a question like that, the major thing that you are tested here is to be able to interchange the log notation to the index notation, and that one you can be able to do it. So the log of 81 base 3 is equals to x. In index notation, this is going to be 3 power x is going to give us now 81. And then when you have the 3 power x is equals to 81, just express 81 in terms of base 3, because they are multiples of 3. So 3 power x will be 81, divided by 3 you get 27, divided by 3 you get 9, divided by 3 you get 3, divided by 3 you get 1. So 81 is the same as 3 power 1, 2, 3, 4. 3 power 4. Hence, our x should be equals to 4. The power that you raise to 3 to get 81 is equals to 4. That power is the same as the log. And let's look at example 2. Example 2, you have been told, that is B, you have the log of x plus the log of 5 is equals to the log of 30. So in other words, we need to be able to solve for x in this case, and on this left hand side of the equation we can have a single log, that is 5, of course x times 5 we get 5x. The log of 5x is equals to the log of 30, and when you have, in that case, the log of 5x is equals to the log of 30, we drop the logs so that you can have, we can equate 5x is equals to 30, because if the log of 5x is equal to the log of 30, then it means that this value here is equals to that value, that is 5x should be equals to 30. So then our x divided by 5, we get x is equals to 6. That is how you solve the second part. Let's look at part C. Part C, we have the log of x base 3 squared minus a half log of x base 3 is equals to 3 over 2. That is what we have. And when you look at it, we have one part is squared, then the other one is not squared. So in this case, we are going to introduce another unknown so that I can be able to solve for x, because it's going to form a quadratic equation because you have one is squared, the other one is not squared. So we can say let the log of x base 3 to be a number like m. Then we replace the log of x base 3 with m. We get here should be given by m squared minus a half m is equals to 3 over 2. And in that case, you can multiply by 2 everywhere so that you can have 2m squared to remove the fractions minus m is equals to 3. And then you can bring this 3 on this side so that you can have a quadratic equation. So 2m squared minus m minus 3 is equals to 0. And then you can find the product, which is equals to 2 times minus 3, get minus 6. Sum is minus 1. And then factors, we have 2 and 3. Then this is minus, so that you can have 2 times minus 3, giving you minus 6. And then 2 plus minus 3, you get minus 1. Then we replace m with 2 and minus 3. So 2m squared plus 2m minus 3m minus 3 is equals to 0. Then factor out what is common, 2m. We remain with m plus 1 because 2m divided by 2m is 1. Then what's common here? We get minus 3 is common. Then we remain with positive m plus 1 is equals to 0. Then these two are common. You take one of them, m plus 1, and we have 2m minus 3. 2m minus 3 is equals to 0. So our m, in this case, we have m plus 1 is equal to 0, or 2m minus 3 is equal to 0. So in this case, we're going to be having m is equals to minus 1, and in this case, we have 2m is equals to, take this on the other side, minus 3, plus the other side is going to be positive 3, and then m will be 3 over 2. And in this case, m is minus 1. So those are two values of m, but our m was the log of x base 3. So the log of x base 3 is equals to minus 1 or 3 over 2. So can write this on the other form. So this is 3 index notation, the log of x base 3, same as now 3 power minus 1 is equals to x, or 3 power 3 over 2 is equals to x. And in this case, 3 power minus 1, that is the reciprocal of that number, so x is equals to 1 over 3, or in this case, x is equals to 3 power 3 over 2. So that is how can be able to solve that kind of question. So let's look at part D. Part D, we have 2 power times 4 power x minus 10, 2 power x plus 8 is equals to 0. Well, how do we go about this kind of a question? So we are going to have this is 2, then 4 power x is the same as 2 power 2x, because 4 is 2 squared, then times x, minus 10 power 2x plus 8 is equals to 0. Then reminding ourselves on the laws of indices, we had where we had a case of a power m times a power n is equals to a power m plus n. And in this case, when you look at the 2 power 2x, it is in this format. There, you can be able to go back on the other side, so this is now our 2 power 2x. So this one is given by what? This is given by 2 power x, then times 2 power x, so that we have the powers to get the 2x. So in this case, I want us to write this in this form, so that we can have now 2 into bracket 2 power x, we multiply by 2 power x minus 10 power 2 power x plus 8 is equals to 0. From there, we're going to let 2 power x be a number like m for us to be able to solve for that particular equation. This one is also going to give us a quadratic equation, and good not be having 2m is now 2 power x is m, so this is m times m, we get m squared minus 10 times m minus 10m, then plus 8 is equals to 0. Then we can be able to get the product here will be 2 times 8, you get 16, the sum be minus 10, then the factors will be two numbers that you multiply them give you positive 16, and then add them they give you minus 10, should be 2 and 8, both of them being minus. So we replace minus 10 with these two, so you get 2m squared minus 2m minus 8m plus 8 is equal to 0. Then factor out what's common, 2 m, then m minus 1 minus, we factorize 8 there, so we get m minus 1 give you c. So 2m minus 8, then we take one of these, m minus 1 is equals to 0. So in this case, we are saying 2m minus 8 is equals to 0, or m minus 1 is equal to 0. Then I take 8 on the other side, 2m is equals to 8, or m is equals to 1. And now that part there you have now m divided by 2 on both sides, m will be equals to 4, or m is equals to 1. But our m was 2 power x, so 2 power x is equals to 4 or 1. And in this case, I can have it as 4 is 2 squared, or 2, 1 is the same as 2 power 0. Any number power 0 is 1. Hence, if this is 2 power x is equals to 2 power 2 or 2 power 0, then our x will be, we're looking at the powers, either 2 or 0. So that's how you can be able to solve that kind of equation. So let's look at part E. We have log 5 squared base x plus log x base 5 is equals to 3. So when you look at this question, you can say that our bases are not the same. This base is x and this base is 5. So we need to, for us to solve this kind of equation, to have this base being the same. And this is where you're going to now use the fourth rule of logarithm, which is, of course, change of the base. And that rule states that if you have a number like this, the log of A base B. If you are to have this, to interchange these bases, it is the same as 1 over the log of now B base A. If you want to interchange the base, then you have to get 1 over that number. So in this case, we can interchange the second one to be having the same base as x, and then that one. So you get to have the log of 5 squared base x plus 1 over the log of now 5 base x is equals to 3. And once you do that, you can be able to see now we have the log of 5x squared base x, and then the log of x 5 base x. And these are now the same. So this is going to be, you can say, you drop this power, so we'll be having 2, the log of 5 base x plus 1 over the log of 5 base x is equals to 3. And then you can let maybe the log of 5 base x to be a number like m. Hence we substitute m in these two, so that I can put together the value of m, and then you have 2 m plus 1 over m is equals to 3. Once it's in that case, you can multiply by 3 everywhere, by m everywhere, so that you can be able to remove this fraction. So you get 2m squared plus 1, then should be equals to 3m. When you multiply by m everywhere, you are going to get that. Multiply by m everywhere, so that you can be able to get that 2m squared plus m to cancel, it became with 1, and then it's going to be 3m. Then you can be able to have from a quadratic equation there, 2m squared, this one, bring it on the other side, you get plus m, and close the equal sign, you will be having minus 3m, then plus 1, going to give us 0. Then you get, you solve that one, for that, in this case, it's going to be 2 times 1, get 2, and then the sum, we're going to be having minus 3. Then the fact has two numbers that when we multiply them, they give you 2, and then they give you minus 3. Those two numbers should be 2 and 1. Minus 2 times minus 1, and multiply them, they give you positive 2, and you add them, they give you minus 3. Then we replace the minus 3m with these two, and then we're going to be having 2m squared, then minus 2m minus m plus 1 is equals to 0, and then 2m is common in these two, we're left with m minus 1, and then minus 1, then m minus 1 should give you 0. So you get, we'll be having 2m minus 1, and then m minus 1 is equal to 0. Then 2m minus 1 is equal to 0, or m minus 1 is equal to 0. And in this case, 2m is equal to 1, and or m is equal to 1. So this one is going to give you m is equals to a half, or m is equals to 1. But our m was log of 5 base x. So log of 5 base x is equals to 1 or a half. In other words, you can be able to write this one in index form: x power 1 is equals to 5, or x power half is equals to 5. So x power 1 is equals to 5, or x power a half is equals to 5 there. and in this case x power 5, this one just x is equals to 5, and the other case all the square root of x power half, that is square root, is equals to 5. So what is that number that when you find the square root to get 5? So the other one should be 25. So our x there is 5 or 25. That's how you can be able to solve that kind of question. Let's look at these two more examples and then we conclude our topic. Now, number 2, I have got solve for log 3 base 8. So we want to solve for log 3 base 8. So how do we answer this kind of a question? So the first thing, the best way is to let this one to be equals to a particular unknown. This can have log 3 base 8 is equals to a number like m. And then when we equate it to a number like m, we can write it into the index notation, where you can have this is going to be 8, this is the base, power m is the one that is giving us 3. And then we introduce logs on both sides. We have now, see, log of 8 power m is equals to the log of 3. And this, of course, power here, you can drop it. You can have m log 8 is equals to the log 3. And then divided by log 8 on both sides. We have m is equals to now the log 3 divided by the log of 8. And using maybe the tables of a calculator, the log of 3 is 0.4771, and then the log of 8 is same as 0.9031. So we divide the two, 0.4771 divided by 0.9031 to get our m is going to be 0.5283. That is now our m. And what is our m? That is our log of 3 base 8 should be now given by 0.5283. So that's how you handle those kind of questions. So let's look at part 3 in the last example. A, we've been taught to get the values of x in A. 6 power x is equals to 15. So 6 power x is equals to 15. We want to get the value of x. So we're going to introduce logs here and have the log of 6 power x is equals to the log of 15. And then you can drop this x, get x. The log of 6 is equals to the log of 15. And then divided by log 6 on both sides. We will be having x is equals to log 15 over the log of 6, and using the calculator, the table, the log of 15 is 1.1761, and then the log of 6 is 0.7782. So when you divide the two, using maybe a calculator there, you're going to be having that is going to be 1.5113. So that is now, you can be able to get the value of x in that case. So let's look at part B, the lead B. we have 3 power x minus 1 is equals to 7. We have to find the value of x in that case. And when you have things like that, so you need to introduce logs on both sides. So you can have the log of 3 power x minus 1 is equal to the log of 7. And then you can drop this power here, x minus 1, you multiply by the log of 3, is going to give you the log of 7. And in this case, divide by log 3 on both sides. So you have x minus 1 is equal to the log of 7 divided by the log of 3. And log of 7 using our calculators there should be 0.8451 divided by the log of 3 is going to be 0.4771. So we divide by 2, we get now our x minus 1 is going to be 1.7713, and divide 0.8451 divided by 0.4771 get us 1.7713. So this is x minus 1. We are interested with x, so we take minus 1 on the other side. We are going to be having 1.7713. This minus 1, it goes to the equal sign, it's going to be plus 1, and then we're going to be having 1 plus 1.771 plus 1 get is 2.7713. So that's how you get the value of x in those scenarios.